All right. Good day and welcome to the interesting session by Tetiana Fydorenchyk. Uh, Tatiana, just to give you a little bit about her background, she's the Vice President of Marketing in Jelestic. It's a multi-cloud PaaS provider serving developers and hosting companies around the world. She's the one responsible for providing executive leadership and management of the Jelestic inbound and outbound marketing activities worldwide, which include corporate partner channel, PR, content, and product marketing activities. Tatiana is responsible for producing articles on tech and business topics connected with cloud computing, containers, DevOps, microservices, multi-cloud, Java, and others. She's very active in organizing and participating at targeted online conference and partners and users webinars. She's very involved in Java community growth by participating in Jakarta EE and micro-profile working groups. So Tatiana's session today is going to talk about running Jakarta EE applications like a cargo tracker inside Kubernetes with a nested container architecture. I will be giving the mic right now to Tatiana to get it on. She will be doing a few slides presentation as well as a demo. So here you go, Tatiana. Mic is yours.
Thank you. Thank you for the introduction. Thank you, everyone who's joining me today in this session. As we mentioned, I'm VP of Marketing in Jelestic company, but recently we had great news that Jelestic was acquired by Virtualization. And right now I'm moving step by step in fully product marketing direction. So this is like the next milestone in my career. So we will see. And today we're going to talk about Jakarta EE applications inside Kubernetes, but not like usual Kubernetes way of hosting, but Kubernetes inside nested containers architecture. And before going on with some details, some theoretical details about the virtualization, how this nested container architecture is working, I would like to say that today I'm going to show also some demo how to deploy cargo tracker application inside Kubernetes with the help of Jelestic Platform as a Service. And to begin with, I would like to start not with the theoretical part, but to go straight to the dashboard and initiate creation of Kubernetes cluster at once. So basically, within Jelestic, Kubernetes cluster is already packaged, and it goes within the marketplace. And you can just click install button, and you will have an opportunity to create the cluster based on your preferences. You can choose the version you want to work with. You can choose Kubernetes dashboard type, ingress controller type, preferable. Also, there is a choice between two different topologies. One of them is development, that goes with one control panel and control plane and one worker. And as well, there is a production option with several workers and more highly available cluster. So you can run Kubernetes like clean cluster totally and then only deploy something inside, or you can at once have some custom stuff inside. By default, Jelestic provides open liberty inside that can be deployed together with creation of the cluster. But of course, you can change this. You can set up your specific project here. So we will go with clean cluster today. And also there is opportunity to enable some modules like Prometheus, Grafana, Dagger, also remote API access. Here within this field, you just specify the name for your environment, and also for a set of cloud providers that we are working with, hosting service providers who are offering Jelestic. They have several data centers, and sometimes you can choose between different regions. So I will choose premium region. This is our demo. So here we also have like multi-region deployment available. So we will go with premium, and I will click install. as you see, the process is already going. You don't need to go inside and do this manually. Everything will be done automatically here after some period of time. For now, we can just roll out this message, and you will see that the process is going on. And at the same time, you see the installation is going, and you can work with the dashboard further if you need to create some other environments or if you need to tune to work with your current ones. And while we are waiting for Kubernetes cluster to be installed, we can go to the presentation and talk a bit about this nested container architecture, as well as what kind of virtualization types are available and why we decided to go with this nested container type. So I'm pretty sure that everyone knows application container, that is popularly known Docker, and the benefits of the Docker were covered like millions of times. So I'm not going to go into details here. But mainly nowadays, Dockers are running inside virtual machines. And this is a good point, but we don't need to forget that there are also system containers, because Docker created some kind of boom around containerization somewhere in 2015. But the containers existed even before that, like for 20 years at the moment, or even more. And these type of containers were like system containers. And the reason why Docker created this boom is that they made containers more convenient and more available for developers. Previously, system containers, they were considered like something that admin guys and system guys are working with and can manage. Right now, with application containers, even developers can manage everything connected with them. So if we are talking about system container right now, I can say that one of them is Virtuoso containers. This is the type of containers that we are working with already for 10 years. Right from the start of the project, we started to run on Virtuoso, as well as Linux containers that are quite popular. And of course, if we compare, we can see that system container is rather close to both sides. Like from one side, system container really close to virtual machines, because it has more or less the same structure, except the guest OS here and in virtual machines. So considering that system containers doesn't have this guest OS, there is no extra resource usage for that. So system containers are more lightweight. They are more lightweight like application containers. But at the same time, system containers closer to virtual machines in terms of security, in terms of isolation, and also in terms of running several services inside. So the difference between application container and system container, like the core difference, I would say, is that with application container, you need to run one service inside one container. With system container, you can run like one main service and some extra services together with that, some SSH daemon or something like that. And this kind of lightweightness made us choose these system containers in order to run Kubernetes services as well. So if we compare like running VM-based host with Kubernetes and container-based host, you can see that this guest OS, it takes and consumes some resources that in case with containers, they can be reused by the applications and by the services that you're running. So you don't need to waste it for the management of the infrastructure, for the management of virtual machines. You can use that space for the application itself and for the services itself. It's even more visible when we check the whole host node, because you can see that the over allocation of the resources here is much higher. Also, you can see that some piece of virtual machine is like light green and dark green. Dark green is really consumed resources, and light green is the resources that are allocated but not really used. And this is a common case with virtual machines, because you're buying a machine and you're buying it full, no matter whether you're using all the resources inside or not. Sometimes you're not using all of them, in most cases, I would say. And all these resources that are available inside virtual machine but not used, they are just wasted because they are waiting its time but not reused. In case with container-based host, all these resources, here you can even see it better, all these resources together, they are available for other services and other applications running. So the density can be much higher because you can put much more applications and much more containers within the host where you don't have VMs on top. And for sure, in terms of running containers inside virtual machines, this option is also available. And why do we need it? For example, you know that most of the cloud vendors, they are running Kubernetes on top of virtual machines. And in order to have some kind of unification for deployment across different cloud vendors, you need to run it the similar way. You need to run them inside virtual machines. So you can run system containers in virtual machines as well. But the question will be from you, maybe, why do we need that, like several layers? Because system containers are more scalable and flexible in terms of resource allocation inside, as well as they are lightweight and they can be rather portable and easy to provision. So this might be also a case if you want to work with several cloud vendors and if you need to have these interconnections and you want to run it on top of different vendors. We even had some kind of demo, and we tried live migration across different clouds with Minecraft game. So one person was playing Minecraft, and we were migrating from Amazon to Azure and from Azure to Amazon, the services. And the player didn't even notice that there were no downtime, there were no issues. The game was going on without any interruptions. So that is a cool system. Of course, for that, you need to have proper configurations. You need to configure networking and everything properly. But this is the next step for multi-cloud and multi-region deployments and availability. And talking about this efficiency, we also need to consider vertical scaling. And comparing vertical scaling of VMs and system containers, we can say that, for example, with VMs, when you grow, you need to buy twice bigger machine because the scaling step is usually twice bigger, like 2 gigabytes, 4 gigabytes, 8, and so on. And in this case, even if you don't use all the resources inside and you buy like twice bigger machine, you still pay for whole machine and for all these resources. And also during this process, you need to migrate. So this leads to some downtime and some extra work. So for sure, this is not very flexible and scalable. In case with containers, the container itself can grow or shrink based on the load. So you can go with one container, you can set up some maximum limits, and the container is going to behave based on the load and provide you the required resources. But when we are talking about vertical scaling, you also need to take into consideration different limits inside, because you need to know what kind of limits you set up for your Kubernetes node, but also what limits you set up for containers and what limits you set up for Java inside. Because for sure, Java can be scalable, and it is already really scalable. But you need to figure out what limits you're setting for your JVM. If, for example, you set the limit too low, then you will have some over-allocation of resources and waste of resources, as this spare space will be just wasted. But from the other point, if you set the limit too high, higher than the limits of the container, you will have out of memory exception or even out of memory kill. And as a result, OS is going to kill your JVM. So this is not the best scenario. So the best scenario is to have these limits rather close to each other, to have JVM limits just a bit lower than containers, just to have some spare space for managing this container. But in general, this should be like rather close, not to over allocate and not to under allocate. And while scaling JVM, while scaling Java, you also need to think about the limits inside it, because Java JVM is also divided to some pieces. And for example, threads, each thread consumes some RAM, and you need to know what limits you require for this number of threads that you're expecting. If you're talking about XMX, this is like heap memory, like the main part. And in terms of this main part in Jelestic, we set up this part for 80% out of all container. So you just, also there is meta space. This is like some system information and some classes or internal objects, some stuff like that, and as well direct memory that is required for some data that should be processed fast. So something rather usual, this is connected with cache servers that can store some data there in order to process it faster than in the main heap. So in terms of this scaling within Jelestic, if you change the limits of container itself, Jelestic system will change all these internal limits for you. So you don't need to go inside container. You don't need to set up new limits for each piece here. Jelestic system is doing that for yourself. Of course, right now, this kind of task requires some kind of update, like you need to restart JVM to apply these changes. And this is not the best case, but right now any other case is not available at the market. So we are working with OpenJDK community in order to introduce the solution for updating the JVM limits and the JVM scaling limits without downtime inside the runtime and without any restart. So this is a bit about Java inside containers inside Kubernetes, so some kind of nested stuff. And let's move on back to the demo. And you see that the Kubernetes cluster is already here. It's already created, and there are some buttons to manage it. Here in this window, you can see that the process is successfully deployed. And here you can go to the dashboard. Let me get inside. Token, sign in. So you see here that the processes, everything is working, everything is fine. And you have the pods and nodes and everything that can be checked within this deployment. And then the other part that we go here is the deployment itself. So today we are going to work with the cargo tracker. And we have this solution already built, this application built on top of Payara server. So you can go to the GitHub repository of Jelestic and find cargo tracker there. And in order to deploy it, we will go to the control plane, and we will go to the WebSSH. And to start with, we need to to start with the WebSSH, sorry. Okay, we need to go inside and check whether the root is available, because as you see inside we have hello world, and cargo tracker requires root context, so we need to delete this hello world. Okay, delete hello world. Okay, you see that it's already deleted, and we can move on with the project itself. So first of all, we will need to clone this project here. So we will clone it like this. And in case if the Git command line interface is not available, you can install it in order to move forward. So you will need to install it. Okay. So here is the installation goes on. Then you need to go to the project directory and apply the required YAM files. So mainly you will need so let's clear the page, and you will need the following files. First of all, this is Postgres secret YAM that is needed in order to get credentials to your database. Postgres YAML that is required to create PostgreSQL database, and also cargo tracker YAML that is required for the deployment of the application itself. So we will start with getting the first file, apply, and okay. Sorry, it seems to me I had some misprinting. Okay, just demo effect, sorry. Maybe I misprinted something. Okay, let me check. So, okay, some trouble as usual with the demos. I'm not sure. Let's check with the other part. Let's clone it again, right? This. We will clone, and we will try to install the file again. Okay, now it's created. Sorry for that, guys. And now we will go to the next file, and we will go for the third file. Here it is. It's created right now, and basically right now everything is already working. But in order to check that everything is properly configured and that everything, all the files are properly installed, we can check each part, and you can see here like that all works properly. Then we check the next one for deployment. You can see here the number of nodes and everything. And the last one, but not the least, and you see that everything is working properly. So after that, you can go to your environment, Kubernetes cluster environment, and you can open in browser. You see the installation, and you can see, sorry, again, some Payara cluster, just again, demo effect, sorry, for that cargo tracker. Yeah, we had to wait a few minutes because the files still had to do this stuff. So you see that cargo tracker is deployed, and right now you can move on with managing. For example, if you need to change the scaling limits. First of all, you can check the statistics, and here you can see that we have like a scaling limit 4 gigabytes, and the environment is consuming only about 1 gigabyte. And the idea within Jelestic is that you're going to pay only for these 1 gigabyte, or if there are going to be some load spike for 2 gigabytes or 3 gigabytes, but not all the time for all these 4 gigabytes, as you would do, for example, while running Kubernetes inside virtual machines. Because within containers, together with our pay-per-use pricing model, you can pay only for the consumed resources. And for example, if you see that the traffic is growing and you think that you need to enlarge the scaling limit, you can go to change environment topology. You can go, for example, here, and you can set up like scaling limit, for example, to 7 gigabytes here, and apply that. So this will take just a few moments. And after applying, you will see that here you see already that it's applied. We can refresh the statistics. Okay, control panel. Close. And we will go to statistics, and you see that we already have 7 gigabytes limit, and still this 1 gigabyte that is really consumed. So basically, you're still going to pay for this 1 gigabyte only, but the limit is already 7 gigabytes. No matter how much you set this scaling limit, you're still going to pay for what you really consume. What else can be done? For example, you can set up horizontal scaling. You can go to the settings, automatic horizontal scaling, and add the triggers. So here you just set up like add nodes and remove nodes based on the load. And you can, for example, do that for memory as well and some other resources. So you can set up like, okay, add some nodes if the load is higher than like 88%, or remove some nodes if the load is lower than some percentage like 51. And you can also have notifications, and you just press add, and you have this logic involved inside. So pretty easy. Right now, the system is going to check your memory, and if the load goes upper, you will get notifications that some worker, some node was added or deleted based on the what is happening inside. Also, what can be done within? So you can go to the add-ons, and here there are a bunch of different add-ons that can help you to manage the cluster. So for example, we have an add-on about cluster upgrade. You don't need to do this manually. All the process that is rather time-consuming, I would say. So here we have like list of what is done inside. But basically, all this work is done just by clicking this button. You just click, say yes, and the cluster will be updated to the next version fully automatically. So this is like in short about possibilities. For sure, there are much more to do, but I see that we are running out of time. And maybe you have some questions, so I would be glad to answer them. And in general, just to summarize that with this kind of running Jakarta EE inside Jelestic Kubernetes cluster, you get fully automated installation. The installation will have the full cluster with everything inside. And you will get also management tools, some add-ons, for example, for updates, some add-ons also for stopping and starting your environment, just in order to cut the costs a bit. And yeah, and generally, and you will get also a choice of different cloud providers where you want to run that. Also, we have a bunch of Jelestic providers, and right now also Virtuoso providers who are going to offer Jelestic locally, where you can run your Kubernetes like multi-region or multi-cloud, or in a single cloud based on your preferences. So, any questions here? Seems to me, no.
All right, Tatiana, thank you so much for your great session. I mean, for folks who would like to ask any questions, please feel free to post your questions in the chat link,
Yeah, you
or click on the
can
Ask a
also
Question.
contact, get in touch with me through Twitter or directly, so you can ask the questions, and I will try to answer all of them.
All right,
Thank you.
absolutely amazing. Thank you so much, Tatiana. And our next session would be with Frédéric Debien. And the title of the session is, Do we really need Kubernetes at the edge? Let's find out. Starting in 2 minutes.